In today's video, we are going to be looking at different scenarios and diagrams and using the information they give us and using Pythagorean theorem, answer any questions or complete any diagrams within those scenarios. So in our first problem, we have an isosceles triangle, has a base of 16 kilometers and an altitude of 10 kilometers, as shown in the diagram. Determine the length of the slanted side to the nearest hundredth of a kilometer. So here's my base. And again, the base doesn't necessarily have to be on the bottom, okay? Because you could technically rotate this triangle to make it go to the bottom. But the reason why they say this is the base is because it has an altitude which forms a 90-degree angle with the base. So here's my base. Here is my altitude, makes a 90-degree angle. Now, being that this is isosceles, that means that these two sides are going to be the same. They're going to be the same measure, whatever they are. Okay, isosceles means two sides are a triangle that has two sides that are equal. So with that, knowing that, we are going to try and figure out how we can use Pythagorean theorem in this scenario to solve for the slanted side, the diagonal here. Now, I know this is an altitude, and which is 10 kilometers. What this does is actually it cuts the base in half. So instead of this whole thing being 16, I'm going to break it down to 8 and 8 kilometers. That way I have one right triangle right here and another right triangle, same thing. And I can use Pythagorean theorem with this right triangle to look for the missing side, which is the hypotenuse, which is the slanted side that we're trying to look for. So we are going to do 10 squared plus 8 squared equals c squared, right? Because technically I'm going to call this c, that side, since I'm looking for the hypotenuse. 10 squared is 100. 8 squared is 64. 100 plus 64 is 164. Square root both sides to get rid of the square. And we get 164 square root is 12.806. So when I round that, it's going to be 12.81. 12.81 kilometers. Okay, you can abbreviate. Okay, so when I round to the nearest hundredth, that means I'm going to two decimal spots. And since I had 12.806, the 6 bumps up the 0 to a 1. Okay, so we've completed that scenario. And again, this is also going to be the same exact thing, right? 12.81. Right, this is 12.81. All right, let's look at another example. There we go, over here. All right. Luke drives 13 miles south, 10 miles east, and 11 miles south again to reach his destination. What is the shortest distance between the starting point and the end point? So Luke drives 13 miles south, 10 miles east, and 11 miles south. Now, I'm trying to find the shortest distance between the start point and end point. Now, if I made a line that connected these, let me do this in a different color. Let me do it in yellow here. Okay. If I try to connect those, this doesn't necessarily cut through the middle. It makes two right angles, right? There's a right angle here and right angle here, but it doesn't necessarily cut through the middle. And I don't know where this crosses over. So we can't really look for this and this without knowing what these sides are. But what we can do is kind of manipulate this diagram here, where I can just move this down, watch, boom, and I can move this over, boom, and now there's my right triangle. Look at that. So just rewind this for a second just to show you again how I did that. So we went south, east, south. And what I did was I moved this guy over here and this person over here. And now I have a right triangle. Or you could make one big rectangle. That's another way you could do it, okay, with this problem. So what am I going to do? Let me do this in purple. So I have my leg here is 10, right? Here's my right angle, right? 13 plus 11 is 24. Okay, so that's my other leg. So I have 10 squared plus 24 squared equals c squared. 10 squared is 100. 24 squared is 576. 100 plus 576 is 676. And then to get rid of the square, I take the square root of both sides, and I get my final answer, which is the square root of 676, which is 26, exactly 26. And again, don't forget your units. We are talking miles. All right. And if it helps to rearrange the diagram like this, you could do that. Or you could also make a just make a rectangle, right? We had this over here, this over here. Those are the same lengths. This is the same length as this. And this is the same. The blue line is the same here. All right. So you can kind of make a rectangle and do the scenario as well. All right. Being that you can't really move line segments on your paper. But another way to do it is just also add up all this distances you're going in the same direction. So 13 south and 11 south, when you add those together, you get 24. That's a leg. And there's only one segment going east, which is 10. All right. So that's it for today's video. Thank you for watching. And always remember, whether you're solving for X or Y, always give math a try.